Good evening students. So in this video we are going to discuss all the major hormones acting on nephrons, right? So we'll just try to understand mechanism of all these major hormones one by one, step by step, right? So let's start with our first hormone, parathyroid hormone, right? Now let's enlarge one cell of PCT, right? And just see how this parathyroid hormone works. Right? Your PTH hormone will act on the PTHR1 receptor, right? It's a G-coupled receptor. Which receptor? PTHR1 receptor, right? Since it's a G-coupled receptor, what it will do? It will convert your ATP to cyclic AMP, right? ATP will get converted to cyclic AMP, which in turn is going to activate your protein kinase C, PKC, right? And what this PKC will do, right? Now how this PCT actually works, right? On the basolateral side, right? We have got a sodium potassium pump. On basolateral side, we have got a sodium potassium pump. And this sodium potassium pump is continuously pumping sodium outside, right? So this reduces the sodium inside the cell. And this gradient is used by many substrates, be it glucose, be it amino acids, or be it phosphates. So one of the ion channels we are having over here is phosphate, sodium phosphate symporter, right? Both sodium and phosphate will be transported at the same time. Means phosphate will use the gradient of sodium. So this PKC is going to inhibit your sodium phosphate symport. If sodium phosphate symport is inhibited, what this will lead to, right? This will lead to phosphaturia. This phosphate will go out, right? And what you will get? Phosphaturia, right? Right? If you saw my previous video of how sunlight helps in vitamin D synthesis, in that I have told that the PTH does very important function in the PCT, because your PCT is very important in the last step of vitamin D synthesis, right? So which step of vitamin D synthesis happens in PCT? Your 1-alpha hydroxylation, right? So vitamin D3, 25 hydroxy vitamin D3 will come into the glomerulus, get filtered out, right? And with the Magellan mediated endocytosis, it will enter the cell, right? And over here in this cell, the PTH is going to stimulate one enzyme, right? Which enzyme? CYP27B1, right? Mnemonic, 27 friends living in room B1, right? It's going to stimulate this enzyme, right? And once this enzyme gets stimulated, right, what it will lead to? It will do 1-alpha hydroxylation of vitamin D, which will give the final form, 1-alpha hydroxylation of vitamin D. Right? So this will finally form the functional vitamin D in the kidney, right? So kidney is very important for producing the functional component of vitamin D, right? This vitamin D will act on your vitamin D receptor, VDR, right? All this is happening inside PCT, right? Vitamin D receptor. Okay, and this vitamin D receptor will finally lead to what? It will lead to upregulation of TRPV5 channel in DCT, right? So this will lead to upregulation of TRPV5 channel in DCT. And what this TRPV5 channel does? This TRPV5 channel increases the calcium reabsorption, right? Absorption of calcium is going to increase, right? So PTH, by stimulating your CYP27B1, will complete the last step of vitamin D synthesis, and this vitamin D synthesis will increase the absorption of calcium. This PTH can also directly stimulate the TRPV5 channel. It can also directly stimulate, right? And this vitamin D action of stimulating TRPV5 channel applies to all the steps of calcium reabsorption. That means it will upregulate your TRPV5 channel. It will also upregulate the calbindin, a protein which binds calcium, calbindin protein. Right? So this will upregulate TRPV5, this will upregulate calbindin, and this will also upregulate the calcium channels present on the basolateral side. Right? On the basolateral side, some calcium channels are present. This will upregulate those channels also. So vitamin D will upregulate all the steps of calcium reabsorption. Right? Now, one very important hormone which acts on PCT is your angiotensin 2. Right? Let's write the name of that hormone, angiotensin 2. Right? This angiotensin 2 will act on AT1 receptor. Which receptor? AT1. Right? Now this AT1 receptor is going to stimulate one very important exchanger over here. Right? There is one exchanger over here which reabsorbs sodium but excretes out hydrogen, sodium hydrogen exchanger. So your AT1 receptor is going to stimulate this exchanger. Now just think of it. If angiotensin 2 stimulates this sodium hydrogen exchange, what is going to happen? The sodium will be reabsorbed more, and wherever sodium goes, the water follows. So amount of filtrate will reduce, and ultimately amount of urine will reduce, right? And amount of ECF will increase. Apart from that, this angiotensin 2, what it does, it causes vasoconstriction of both afferent and efferent arterioles. It is going to constrict both afferent and efferent arteriole. And what constriction of afferent arteriole can do, right? Constriction of afferent arteriole will reduce GFR, right? But constriction of efferent arteriole is going to increase GFR. But which effect is going to predominate? Decrease in GFR is going to predominate of these two effects, right? The GFR ultimately decreases, right? So what this angiotensin 2 is doing, right? First of all, it is constricting both these arteries, right? So amount of GFR is reduced, amount of filtrate is reduced, and in this reduced filtrate, it is causing even more reabsorption, right? So the amount of filtrate reduces further. What else angiotensin does? Angiotensin will send a message to hypothalamus. And what message it will send to hypothalamus, right? By acting on hypothalamus, it is going to increase the level of ADH. And what ADH will do? ADH will further absorb water from this filtrate by acting on the collecting ducts, right? So it will further reduce the quantity of urine, right? What else it does? It can increase the thirst. It can stimulate the thirst center by acting on the hypothalamus. So if you just look at all the actions of angiotensin 2, by all its action, it is actually increasing your ECF, extracellular fluid volume. How? By constricting both afferent and efferent arteriole, right? Especially the afferent arteriole constriction. It is going to reduce the overall GFR, right? The reduction in GFR because of constriction of the afferent arteriole is going to dominate over the constriction of efferent arteriole. So ultimately the GFR will be reduced. If GFR reduces, of course the ECF volume will increase, right? Apart from that, it will stimulate your sodium hydrogen exchanger. If more sodium is reabsorbed, the more water will be reabsorbed, amount of filtrate will reduce. But since the more water is reabsorbed from here, right, of course the ECF will increase, right? If ADH level increases, more water will be reabsorbed, amount of ECF will increase. If thirst center is stimulated, you will drink a lot more water, ECF volume will increase. So through all its actions, your angiotensin 2 is actually increasing the quantity of ECF, right? So one sole purpose of angiotensin is to increase the volume of ECF, right? Now, one very important hormone which we need to discuss is which acts on the ENaC channels, right? Principal cells. Let's draw our principal cells first of all. What lies on the basolateral side of principal cells? Our main hero, sodium potassium pump. This will reduce the sodium inside and the sodium will come through the ENaC channels using this gradient, right? And apart from that, you will have ROMK channels. Why you need ROMK channels? Because when sodium goes through this side, the whole inside of the collecting duct becomes negative, right? And this sucks out which ion? Potassium ion outside, right? So you got ROMK channels, right? Now there is one hormone called aldosterone, right? Now aldosterone stimulates all these steps. Aldosterone stimulates all these steps. It stimulates your sodium potassium pump. It stimulates your ENaC channels. It stimulates even the ROMK channels. So aldosterone stimulates all these steps. Apart from that, aldosterone also acts on the intercalated cells, right? In intercalated cells, you have got one ion channel called H plus ATPase, right, which pumps out H plus ion, H plus ATPase. So aldosterone will act even on H plus ATPase, right, excrete out H plus ion. So what will happen if aldosterone increases, right? More sodium will be reabsorbed because ENaC channel is stimulated, right? And more sodium will be absorbed further basolaterally, right? Which leads to further reabsorption of sodium. So a lot of sodium is reabsorbed, lot of water is reabsorbed, which increases your ECF volume, and lot of H plus is excreted out, which causes, if H plus is excreted out, what it will cause? Alkalosis, right? So you will have sodium and water retention and alkalosis in case the aldosterone increases, right? One very important hormone we still need to discuss is your antidiuretic hormone, right? ADH. Okay. Now, how ADH works? ADH will act on the V2 receptors. Your ADH will act on V2 receptor. Right? By acting on the V2 receptor, what it will do? It will convert your ATP to cyclic AMP. It will increase the level of adenyl cyclase, right? I'll write in short form AC. And what it will do? It will convert your ATP to cyclic AMP. And this cyclic AMP, what it will do? It will increase the level of protein kinase. And what this protein kinase will do? It will increase the recruitment of aquaporin 2 channels. And what these aquaporin 2 channels will do? These aquaporin 2 channels are going to reabsorb your water, right? The water will be reabsorbed through this aquaporin 2, right? And it will be further transported on the basolateral side with the help of aquaporin 3 and 4, right? Aquaporin 3 and 4 on this side will further transport it basolaterally. Apart from that, ADH also helps in the urea cycle, right? So you will have UTA1, right? Reabsorbing urea through this UTA1, right? And through UTA3 it will be reabsorbed further, right? UTA3 it will be reabsorbed on the basolateral side, right? So ADH is a very important hormone. It reabsorbs water through aquaporin 2 channels and transports it basolaterally, right, through aquaporin 3 and 4, right? It reabsorbs urea through UTA1 channels and transports it basolaterally through UTA3, and the whole urea cycle is going to repeat, going through the thin ascending limb and coming back to the collecting duct, right? Now this is overview of ADH, right? One very important hormone we still need to discuss is our ANP, right? Now how does ANP works, right? This ANP is going to act on your NPR1 receptor, right? Now we will draw one cell of this artery over here, right? ANP. This ANP will act on which receptor? NPR1 receptor. What's the name of this receptor? NPR1. Right? And what this NPR1 is going to do? Your NPR1 is going to increase the level of cyclic GMP. And what this cyclic GMP will do? This cyclic GMP will increase the level of protein kinase. And what this protein kinase will do? Right? This protein kinase will cause vasodilation of this artery, right? And what vasodilation can do? Vasodilation will lead to increase of GFR. So it will increase GFR by vasodilating the arteries. Apart from that, this your ANP is going to inhibit what? It's going to inhibit your sodium hydrogen exchanger, right? It's going to inhibit the sodium hydrogen exchanger. And if it inhibits your sodium hydrogen exchanger, what it will lead to? It will lead to natriuresis. Right? Apart from that, your ANP is also going to inhibit your ENaC channels. It's going to inhibit your ENaC channels. Right? Now, if it inhibits your ENaC channel, what it will lead to? It will again lead to natriuresis. So, ANP through all its actions is actually increasing the excretion of sodium and water and reducing the ECF volume. How? ANP, by acting on the arteries, right? It is causing vasodilation. So it is increasing the level of GFR, right? If GFR increases, of course, you will get more urine, right? It is reducing the activity of sodium hydrogen exchanger. So no more sodium will be reabsorbed, the water won't come back, all this will stay inside the tubule and excreted out. So natriuresis. ENaC channels, these ENaC channels won't reabsorb sodium, sodium will stay here and sodium and water will be excreted out. So all the actions are leading to natriuresis and reduction in the ECF volume, right? One very important hormone is synthesized in your DCT, right? And what's the name of that hormone? Urodilatin, right? Urodilatin. And what this hormone does, right? This hormone inhibits all the steps, right? Which you can see, which the aldosterone supports, right? So it inhibits your ENaC channels, right? It inhibits your ROMK channels, right? And it inhibits sodium potassium pump, right? And it also inhibits the action of ADH. Just think of it. If ENaC channel is inhibited, ROMK channel is inhibited, sodium potassium pump is inhibited, and ADH is inhibited, what ultimately you will get? You will again get what you call natriuresis. Urodilatin will also cause natriuresis, right? Apart from that, there is one enzyme called FGF23, right? FGF23, right? This will also inhibit your sodium phosphate symporter, right? So this will also lead to phosphoturia, right? Apart from that, there is one more enzyme called hormone called dopamine, right? Dopamine. What this dopamine is going to do? This dopamine is going to inhibit your sodium hydrogen exchanger, right? Just think of it, if this dopamine inhibits your sodium hydrogen exchanger, what is going to happen? The sodium won't be reabsorbed, sodium will stay over here, water will follow, and you will ultimately get in this situation also natriuresis, right? Okay, so it's an interesting interaction of all the hormones, right? So let's try to sum it up, right? Parathyroid hormone, by acting on the PTHR1 receptor, right? What it is ultimately going to do? It is going to inhibit your sodium phosphate symporter. So what it will lead to? It will lead to phosphoturia. But parathyroid hormone, it also stimulates one enzyme called CYP27B1 and finishes the last step of vitamin D synthesis, 1-alpha hydroxylation, which synthesizes your 1,25 hydroxy D3, the final form of vitamin D3. What vitamin D is going to do? It is going to upregulate your TRPV5 channel, also upregulate calbindin, also upregulate the calcium ion channel on the basolateral side of the DCT cells, right? Apart from that, you got very important hormone called angiotensin 2. It will act on the AT1 receptor and stimulate your sodium hydrogen exchanger. So more sodium is reabsorbed, more water is reabsorbed, which leads to increase in ECF. Apart from that, it is going to constrict both your afferent and efferent arteriole, but constriction of afferent arteriole leading to reduction of GFR will predominate. Reduction of GFR means more ECF. Apart from that, angiotensin 2 will act on hypothalamus. It will increase the level of ADH. So ADH will reabsorb water. More reabsorption of water means higher ECF. It will also stimulate your thirst center. More stimulation of thirst center, you are going to drink more water, more ECF, right? Apart from that, you have got a hormone called dopamine. It will inhibit your sodium hydrogen exchanger. So more sodium will be excreted out in urine. It will lead to natriuresis. Apart from that, you have got one very important hormone over here, aldosterone, right? Aldosterone is going to stimulate your ENaC channel, your ROMK channel, and also your sodium potassium ATPase pump. So more sodium absorption, more water reabsorption, leading to less urine, right? That means sodium and water retention. It will also stimulate your H plus ATPase. So more aldosterone means alkalosis, right? Your ADH, right? It helps in reabsorption of water via the recruitment of aquaporin two channels. Apart from that, it has also got an important role of in urea cycle, right? It reabsorbs urea through UTA1, right? And secretes it out basolaterally through UTA3. It reabsorbs water through aquaporin 2 and secretes it out basolaterally through aquaporin 3 and aquaporin 4. Apart from that, there is one very important hormone, urodilatin. This urodilatin is synthesized in your DCT, right? But it inhibits all these steps of ENaC, ROMK and sodium potassium ATPase pump. It also inhibits ADH, which leads to natriuresis and diuresis, right? And apart from that, there is one FGF23, right, which is going to inhibit your sodium phosphate syn-porter, and this will also lead to phosphaturia. So hopefully this video has helped you in gaining better understanding of how exactly all these hormones act and interplay, right, to produce various physiological effects, right? Wish this video helped you in better understanding of it, right? Wish you all the very best. Thank you.